Okay, so Chris, now we're going to talk a little bit about natural language processing, natural language understanding, and really in using it for understanding customer intent. So we've been doing a lot of work lately for our clients using RPA to automate repetitive tasks like looking up and sending out a customer's loan statement, or maybe sending out letters of appeal for healthcare providers, and even filling out online state and county sales tax forms. Pretty tedious stuff. But we've been especially busy helping our clients in financial services industries dealing with the economic fallout from COVID-19. And one of our clients is in the auto financing business, and they have been inundated with requests from borrowers to defer payments on their loans. So we built a bot that works through their existing process to their existing system to process these requests to modify a borrower's loan to defer up to, in most cases, 3 payments. And using RPA in this way is great because the robots can basically work their fingers to the bone and chew through all this backlog of the tens of thousands of requests for payment assistance in just a few days. And where this would actually take humans months to go through all of that work. Now, the only problem with this approach is that it requires 2 things. First of all, you need to know that the borrower is actually requesting a payment or requesting payment assistance. And then secondly, you need to know the number of payments that they're really trying to defer. So if the lender receives this information through, say, their website, where the borrower might be able to click on a link, request payment assistance, and then fill out some form, which includes the number of payments that they want to defer, then we'd be good to go. But a lot of financial institutions don't work that way. Instead, they're providing they provide what's really a self-service website or a self-service portal where the customer can, well, what they can't do is they are not providing a self-service website where the customer is able to, hunt around and find what they're looking for. Instead, what many lenders are doing is they're providing a secure messaging service where the customer can submit their request, and then a human customer service agent reads that message and then responds with the appropriate action. So you can imagine during this pandemic, these tens of thousands of requests for payment assistance are mixed in with requests for other things, like reprints of their loan statement, maybe because they were filing their taxes, or an explanation of why a late payment fee was being charged. And some of these requests can be processed by RPA bots, while others require a human to do the work. So for the ones that we can automate with RPA, the challenge is understanding the language in that request and then invoking the right bot. So now imagine you were working in customer service for, say, an auto lender, and you're responding to customer messages being sent through this secure messaging portal. And also, let's assume that we've created some RPA bots to help you out. We've got one for that automates the request for deferral for a given number of loan payments. And then we have another one that sends out loan statement reprints on request. Now, what you have to do here is really 2 things. First, we want to be able to leverage these RPA bots to automate the processing of payment deferrals and statement reprints. But then also, we want to teach our robots to understand these customer requests so that it can separate out the requests for that basically we can automate from the ones that need to be handled by a human. So what we've done is we're diverting messages from the secure messaging queue and routed them through our robot request router. And the robot request router actually uses artificial intelligence, more specifically natural language processing and machine learning, to classify this unstructured text and extract the relevant pieces of data from the messages. When we begin this process, our robot isn't really smart, but our message labeling team from customer service, which is really just people who have been trained to answer these questions and deal with the responses directly, they're gonna actually start teaching the robot to recognize the different types of customer requests, as well as to recognize the parameters needed by the RPA bots to automate those requests. Over time, the robot learns to understand the content of these customer messages more and more, and what's going to end up happening is that more and more of that work will then actually get directed directly to our robots. So let me give you an example. So here's a first message from a customer that goes to our customer service labeling team to process. And this message came from a borrower who is asking to defer 3 payments on their car loan. And the first thing that we're actually going to do is we're going to classify this message. And since this is a request for payment assistance, we're going to select the first option, and then we're going to go ahead and click Next. And the other piece of information that we're interested in is the number of payments that they want to defer. And to capture that, we'll highlight the number 3, and then we're going to select requested duration. Now, when we click Submit, 2 things are going to happen. Since we've created a bot to automate the payment deferrals, the information from this message will be routed to our robot request router to the payment deferral bot. And that bot then is going to automate the processing of that request. But the other thing that's going to happen is that the training data that we've just created by labeling this message will then be used in the background to start training our machine learning algorithm to recognize similar messages so that it can start doing the work of labeling on its own. All right, here's the next message. This one is a customer is asking for a reprint of their December 2019 loan statement. And we're going to classify this as request statement. And for statement requests, we want to pull out the month and the year for the statement being requested. And to do that, we're going to highlight those pieces of the message and then select the month and the year labels. All right, now things are starting to get interesting. So remember when I said that the training data gets fed back into our machine learning algorithm so that it can start labeling the messages on its own? Well, here's the first time that we start to see the AI getting smarter. This is another message requesting payment assistance. And if you look over on the right, you're going to see a 20% and next to the request payment assistance option. And what that means is that before we are shown this message, the machine learning algorithm already had tried to classify. And in this case, it was only 20% confident that of the result. So not really good enough for us to let it fly solo, because we've actually set the threshold of that to 65% before we let the algorithm label something on its own. So here, we're going to confirm that this is a request for payment assistance. And now we're going to identify the requested deferral duration. Okay. Now here's a request that we can't automate right now. It's really just too complicated. But that's okay. We're going to classify it as other, and then our router will be able to forward it back to the queue to be processed by a human. All right. Now we're getting somewhere. Our machine learning algorithm has looked at this message and is 67% confident that it's a request for payment assistance. And since this is above that threshold of 65%, it'll automatically just go through the process. But it was only 45% confident it could identify the requested duration, so we need to give it a little bit of help. So as our labeling algorithm gets more and more data, it gets smarter and is able to do more of the labeling work on its own. Once it's trained, occasionally it's going to come across a message that it can't understand. But the customer service labeling team will catch that message because the pre-labeling confidence level of 65% won't have been met. Eventually, over time, though, the labeling algorithm should be able to process even those more difficult messages. So this combination of artificial intelligence and RPA is one of the ways that our clients can evolve from simply automating mechanical activities to incorporating cognitive capabilities that drive them more towards intelligent automation. So if we look at this from what we call a reference architecture for this solution, What we've just looked at is an example of what's called augmented intelligence, and it's actually coupled with machine learning and RPA. And one of the advantages of this approach over some of the other applications of just pure machine learning is that you start getting a return on your investment the day you turn it on. Now, one of the challenges of machine learning by itself is that even when you turn it on, you have to actually power it with a lot of data, and pulling all that data together can take a lot of time and cost a whole lot of money. But the approach that we've used here doesn't actually require that you start off with an initial large training set of data, and instead you label the data as you go while reducing the overall effort to your internal teams. So certainly the solution will become much better over time, but by using augmented intelligence, you're able to bridge that data gap and have the solution begin paying for itself much sooner.